In this video, we're going to cover the why behind Node.js. Why is it so good at creating back-end apps? And why is it becoming so popular with companies like Netflix, Uber, and Walmart all using Node.js in production? As you might have noticed, since you're taking this course, when people want to learn a new back-end language, more and more they're turning to Node as that language they want to learn. The Node skill set is in hot demand for both front-end developers who need to use Node day to day to do things like compile their applications, to engineers who are creating applications and utilities using Node.js. All of this has made Node the prime choice in 2016 as the back-end language of choice. Now, I've left this homepage up for a reason. In the last video, we addressed the first sentence. We took a look at Node.js, and we learned that it's built on top of the V8 JavaScript engine. There's only 3 sentences here, so in this video, we're going to take a look at the second 2. We're going to go ahead and read them now, then we'll break it down, learning exactly why Node is so great. The first sentence, Node.js uses an event-driven, non-blocking I/O model that makes it lightweight and efficient. We're going to explore all of that in just a second. The second sentence, which we'll explore at the end of the video, Node.js's package ecosystem, NPM, is the largest ecosystem of open source libraries in the world. Now, these 2 sentences, they have a ton of information packed into them. The second sentence has a lot more packed in than the third. What we're going to do is go over a few code examples. We're going to dive into some charts and graphs, and we'll explore what makes Node different and what makes it so great. Node is an event-driven, non-blocking language. Now, you see non-blocking I/O right here. What is I/O? I/O is something that your application does all of the time. When you're reading or writing to a database, that is I/O, which is short for input-output. This is the communication from your Node application to other things inside of the Internet of Things. This could be a database read and write request. You might be changing some files on your file system, or you might be making an HTTP request to a separate web server, such as a Google API for fetching a map for the user's current location. All of those use I/O, and I/O takes time. Now, the non-blocking I/O is great. That means while one user is requesting a URL from Google, other users can be requesting database, file read and write access. They can be requesting all sorts of things without preventing anyone else from getting some work done. Let's go ahead and take a look at the difference between blocking and non-blocking software development. Right here, I have 2 files that we're going to be executing in just a minute. But for the moment, we're going to explore how each operates, the steps that are required in order for the program to finish. This is going to show us the big differences between blocking, which I have on the left, which is not what Node uses, and non-blocking on the right, which is exactly how all of our Node applications in the course are going to operate. You don't have to understand the individual details like what require is in order to understand what's going on here. We're going to be breaking things down in a very general sense. The first line on each is responsible for fetching a function that gets called. And this function, this is going to be our simulated I/O function that is going to a database, fetching some user data and printing it to the screen. Both files do the same thing, they just do it in different ways. After we load in the function, both files try to fetch a user with an ID of 123. When it gets that user, it prints it to the screen with the user1 string before. And then it goes on and it fetches the user with 321 as the ID. It prints that to the screen. And finally, both files add up 1 plus 2, storing the result, which is 3, in the sum variable and printing it to the screen. Now, while they all do the same thing, they do it in very different ways. Let's break down the individual steps. Down below, we're going to go over what Node executes and how long it takes. You can consider these seconds. It doesn't really matter. It's just to show the relative operating speed between the 2. The first thing that happens inside of our blocking example right here is we fetch the user on line 3. Now, this request requires us to go to a database, which is an I/O operation, to fetch that user by ID. This takes a little bit of time. In our case, we're going to say it takes 3 seconds. Next, on line 4, we print the user to the screen, which is not an I/O operation, and it runs right away, printing user1 to the screen. You can see that takes almost no time at all. Next up, we go ahead and we wait on the fetching of user2. When user2 comes back, as you might expect, we print it to the screen, which is exactly what happens on line 7 right here. Finally, down below, we add up our number and we print it to the screen. None of that is I/O, so right here we have our sum printing to the screen in barely any time. This is how blocking works. It's called blocking because while we're fetching from the database, which is an I/O operation, our application cannot do anything else. This means our machine sits around idle waiting for the database to respond and can't even do something simple like adding two numbers and printing them to the screen. It's just not possible in a blocking system. On the right, we have our non-blocking example. This is how we're going to be building our node applications. Let's go ahead and break this down line by line. First up, things start much the same way. We're starting the getUser function for user1, which is exactly what we do here. But we're not waiting. We're simply kicking off that event. This is all part of the event loop inside of Node.js, which is something we'll be exploring in detail. Notice it takes a little bit of time. We're just starting the request. We're not waiting for that data. The next thing we do might surprise you. We're not printing user1 to the screen because we're still waiting for that request to come back. Instead, we start the process of fetching our user with the ID of 321. Here we're kicking off another event, which takes just a little bit of time to do. It is not an I/O operation. Now behind the scenes, the fetching of the database is I/O, but starting the event, calling this function is not, so it happens really quickly. Next up, we print the sum. The sum doesn't care about either of the two user objects. They're basically unrelated. So there's no need to wait for the users to come back before I print that sum variable. Down below, after we print the sum, what happens? Well, we have this dotted box. This is the simulated time it takes for our event to get responded to. Now, this box, it is the exact same width as the box over here. Using non-blocking doesn't make our I/O operations any faster. But what it does do is it lets us run more than one operation at the same time. Here, we start two I/O operations before the half-second mark, and right here between 3 and 3.5 seconds, both come back. Now, the result here is that the entire application finishes much quicker. The non-blocking version finishes in just over 3 seconds, while the blocking version takes just over 6, a difference of 50%. And that 50% comes from the fact that here we have two requests, each taking 3 seconds, and here we have two requests, each taking 3 seconds, but they run at the same time. Using the non-blocking model, we can still do stuff like printing the sum without having to wait for our database to respond. Now, this is the big difference between the two. Blocking, everything happens in order, and in non-blocking, we start events attaching callbacks, and these callbacks get fired later. We're still printing out user1 and user2, we're just doing it when the data comes back, because the data doesn't come back right away. Inside of Node.js, the event loop attaches a listener for the event to finish, in this case for that database to respond back. When it does, it calls the callback you pass in right here, and then we print it to the screen. Now imagine this was a web server instead of the current example. That would mean if a web server comes in looking to query the database, we can't process other users' requests without spinning up a separate thread. Now Node.js is single-threaded, which means your application runs on one single thread. But since we have non-blocking I/O, that's not a problem. In a blocking context, we could handle two requests on two separate threads, but that doesn't really scale well because for each request, we have to beef up the amount of CPU and RAM resources that we're using for the application. And this sucks because those threads, they're still sitting idle. Just because we can spin up other threads doesn't mean we should. We're wasting resources that are doing nothing. Here, instead of wasting resources by creating multiple threads, we're doing everything on one thread. When a request comes in, the I/O is non-blocking, so we're not taking up any more resources than we would be if it never happened at all. Let's go ahead and run these examples in real time and see what we get. And right here, we have the two files that we saw over in the screenshot. We're going to be running both of these files, and I'm using the Atom editor to edit my text files. These are things we're going to be setting up later in the section. This is just for your viewing purpose. You don't need to run these files, so they're not provided. Now the blocking and non-blocking files, they're both going to get run and they're going to do similar things, obviously just in a different way. Both use I/O operations, getUserSync and getUser, that take 5 seconds apiece. The time is no different, it's just the order they execute in that makes the non-blocking version much quicker. Now to simulate and show how things work, I'm going to add a few console.log statements right here, starting user1. starting user 2. This is going to let us visualize how things work over inside of the terminal. I'll have starting user 2 and starting user 1. Perfect. Once again, as I promised, this is never going to come up again where you're just watching me magically create code. For now, though, we're going to start by running the blocking file over in the terminal. By running node blocking.js, this is how we run files. We type node and we specify the file name. When I run the file, we get some output. Starting user 1 prints to the screen, and then it sits there. Now we have the user 1 object printing to the screen with the name Andrew, and starting user 2 prints to the screen. After that, the user 2 object comes back around 5 seconds later with a name of Jen. Our two users have printed to the screen, and at the very end, our sum, which is 3, prints to the screen. Everything works great. Notice that starting user 1 was immediately followed by the finishing of user 1, and starting user 2 was immediately followed by the finishing of user 2, because this is a blocking application. Now we're going to run the non-blocking file, which I called nonblocking.js. When I run this file, starting user 1 prints, starting user 2 prints, then the sum prints all back to back. Around 5 seconds later, at basically the same time, user 1 and user 2 both print to the screen. This is how non-blocking works. Just because we started an I/O operation doesn't mean we can't do other things, like starting another one and printing some data to the screen. In this case, just a number. This is the big difference, and this is what makes non-blocking apps so fantastic. They can do so many things at the exact same time without having to worry about the confusion of multi-threading applications. Let's go ahead and move back into the browser and take a look at those sentences again. Node uses an event-driven, non-blocking I/O model that makes it lightweight and efficient. And we just saw that in action. Because Node is non-blocking, we were able to cut down the time our application took by half. This non-blocking I/O makes our apps super quick. This is where the lightweight and efficient comes into play. Now let's go to the last sentence. Node's package ecosystem, NPM, is the largest ecosystem of open source libraries in the world. This is what really makes Node fantastic. This is the cherry on top, the community, the people every day developing new libraries that solve common problems in your Node.js applications. Things like validating objects, creating servers, and serving up content live using sockets. There's libraries already built for all of those, so you don't have to worry about this. This means that you can focus on the specific things related to your application without having to create all this infrastructure before you can even write real code that does something specific to your app's use case. Now, NPM, which is available over on npmjs.org, is the site we're going to be turning to for a lot of third-party modules. If you're trying to solve a problem in Node that sounds generic, chances are someone's already solved it. For example, if I want to validate some objects, let's say I want to validate that a name property exists and that there's an ID with a length of 3. I could go into Google or go into NPM. I usually choose Google, and I could Google NPM validate object. When I Google that, I'm just going to look for results from npmjs.com, and here you can see the first 3 or so are from that. I can click the first one. This is going to let me explore the documentation and see if it's right for me. This one looks great, so I can add it to my app without any effort. Now, we're going to be going through that process. Don't worry, I'm not going to leave you high and dry on how to add third-party modules. We're going to be using a ton of them in the course because this is what real Node developers do. They take advantage of the fantastic community of developers. And that's the last thing that makes Node so great. This is why Node has come to the position of power that it currently sits at. Because it's non-blocking, meaning it's great for I/O applications, and it has a fantastic community of developers. So if you ever want to get anything done, there's a chance someone already wrote the code to do it. This is not to say you should never use Rails or Python or any other blocking language again. That is not what I'm getting at. What I'm really trying to show you is the power of Node.js and how you can make your applications even better. Languages like Python have things like the library Twisted, which aims to add non-blocking features to Python, though the big problem is all of the third-party libraries, those are still written in a blocking fashion, so you're really limited as to which libraries you can use. Since Node was built non-blocking from the ground up, every single library on npmjs.com is non-blocking. So you don't have to worry about finding one that's non-blocking versus blocking. You can install a module knowing it was built from the ground up using a non-blocking ideology. That is it for this 2-video series looking deep into what Node is and why it's so great. In the next couple of videos, you're going to be writing your very first app and running it from the terminal, so stay tuned. I am super excited to show you how.